Hi, it's Mrs. Goodson here, and this is a video about structural isomers. So I'm going to introduce the idea of what is an isomer, what are the different types of isomers, and then we're going to look at structural isomers, or also known as constitutional isomers. And I'm going to give you some examples of how to draw alkane isomers when you're given the molecular formula. So what are isomers? Isomers are any of two or more substances that are made up of the same elements in the same proportions. That is, they have the same molecular formula, but they differ in the properties because of differences in the arrangement of atoms. And that means that they have a different structural formula. So for level 2 chemistry, we're going to look at, so these are the different kinds of isomers. This video is about structural isomers, and then we're going to look at chain isomerism and positional isomerism. And then later on in future videos, we're going to look at functional group isomerism and geometric isomerism. That's what you need to know for level 2 chemistry. So structural isomerism. Compounds have the same molecular formula but different structural formula. There are three types. Chain isomerism, where two or more, so chain isomerism is when two or more compounds have the similar or the same molecular formula but different carbon skeletons. Position isomerism is when two or more compounds differ in the position of the functional group on the same carbon skeleton. And functional group isomerism is when two or more compounds have the same molecular formula but different functional groups. And in this video, we're going to concentrate on chain isomerism. So, chain isomerism. So methane, ethane, and propane all have no structural isomers. There's only one way of drawing them. Well, as you get bigger chains, then you can have different arrangements. So butane has two different arrangements, and it's still called butane. Pentane has three different arrangements. Hexane has 5. Heptane has 9. And if you get up to C30, which is called triacontane, then it's over 4,000 million different combinations of how you can draw it. But we're in level 2 chemistry, we're only worried up from carbon 1 to carbon 8. So let's have a look at this example, butane. Butane has the molecular formula C4H10, okay? So C4H10, so that means that for every carbon, there's 2N plus 2 hydrogens, okay? So the plus 2 is the hydrogens on the end, and then each carbon's got 2, okay? So there's 2 possible arrangements for butane, for the formula C4H10, because if it's a straight chain, then it's butane, 1, 2, 3, 4, butane. However, if we take one part of it, we take this part here and we make it a methyl group attached to carbon 2. So this would be 1, 2, 3. The longest carbon chain is 3. So it's propane and with a methyl group attached. So the methyl group can only go in one place. So it doesn't need a number. It's just methyl propane. So butane and 2-methylpropane are structural isomers. They have the same molecular formula, C4H10, but different structural formula. So that is an example of isomers. Example 2. Pentane has the molecular formula C5H12, and there are 3 structural isomers. So this would be pentane 1, 2, 3, 4, 5, straight chain, pentane. However, the longest chain on this one is 1, 2, 3, 4, so it's butane. And the methyl group is attached to, so now I've numbered it from that end. We'll just write that out. So make sure that you number it so that the side chain is the smallest number possible. So it's better, it has to be numbered from this end, 1, 2. So that's why it's 2-methyl. There's the methyl group. It's attached to carbon 2, so it's 2-methylbutane. But it has the same number of carbons and hydrogens as pentane, which is C5H12. So these 2 molecules are structural isomers of each other. And then there's one further way that you can draw C5H12, and that is if you have a methyl group here and a methyl group here, and the longest chain, no matter which way you look at it, is 1, 2, 3. So it's propane. Got 2 methyl groups, so it's dimethyl, and it's 2,2-dimethyl propane. The 2 methyl groups hang off the second carbon, and the longest unbroken chain is 3 carbons, so it's propane. So these 3 molecules are structural isomers of each other. Okay, so here is a practice exercise for you. So what I want you to do is to draw and name the 5 isomers of hexane, C6H14. So I want you to pause the video now and have a go at drawing the 5 isomers of hexane, C6H14. Okay, I'll pause the video now. Okay, you're back again. So I'm going to show you the answers. So we've got hexane. So first one, easiest one to draw. In my answers, I haven't put all the hydrogens on, but you would need to do that in exam. So I've just made it so you can see the carbon chain. So we've got hexane, and then we've got put a methyl group on the side. So we've got 2 methyl pentane, 1, 2, 3, 4, 5 is the longest chain. Or we could put the methyl group of carbon 3. So then we've got 3 methyl pentane. So those are isomers of each other. Okay, then we can shorten the chain. We've got butane. We still need 6 carbons, 1, 2, 3, 4, 5, 6. We could put the methyl groups off these ones here, and the longest chain is 4. So it's butane, 2, 3 dimethyl butane. Or you can put the methyl groups both off. So this would be 1, 2, 3, 4. So it's butane, and the methyl groups are attached to 2. So it's 2, 2 dimethyl butane. Hope you got those right. Okay, this is practice exercise 2. Here are the carbon frameworks for the 9 isomers of the formula C7H16. And what I want you to do is to name them. Okay, so we've just drawn them without the hydrogens, but the hydrogens are there. So pause the video now, and then you can come back and see the answers. So pause now. Okay, so let's go through the answer for this one. So we've got C7, so the first one is heptane, and then we've attached the carbon, 1 carbon here. We've shortened the chain to 6, so we need 1 methyl group. So we've got 2 methyl hexane and 3 methyl hexane. Or we could shorten the chain to 5, so then we've got pentane, and then we need 2 methyl groups, so it's 2, 3 dimethyl pentane, or 2, 4 dimethyl pentane, or 2, 2 dimethyl pentane, okay? Or 3, 3 dimethyl pentane. So you can play with where the methyl groups go. Just make sure that you, when you're doing isomers, that you don't do the same molecule, but just drawn differently. Okay, so this is still pentane. The longest chain is 5, even if you go around the corner here. 1, 2, 3, 4, 5. 5 is the longest, so it's pentane, but it's got an ethyl group. So it is 3-ethyl pentane. Then we've gone shorter, so we've got the longest chain is 4, so this is butane. Then we've added methyl groups so that we've got 7 carbons. So this one is called 2,2,3 trimethyl butane. Okay, so I hope you did well with that. Okay, this is an extra for experts. Do isomers have different properties? The difference in the structures of the isomers tends to give the molecules different physical properties. For example, butane has a boiling point of -1 degree centigrade, whereas methyl propane, and I've got those structures over here, so butane is a straight chain molecule, whereas methyl propane is a branch, it's got a bit of a branch going on. It's got the same number of carbons and hydrogens, so it's the same size, but a different boiling point. So how can we explain that? So what happens is the straight chain has a higher boiling point than the branch chain, and this is because it has a greater surface area in contact with the molecules next to it, and so it has bigger or greater intermolecular forces between the adjacent molecules, and these intermolecular forces can be called van der Waals. You might see them called van der Waals forces. So if you have the branches, the molecules held together a bit better, so they need more energy to separate them. So that's why they have a higher boiling point. Another example is the two isomers of hexane, 2,2-dimethylbutane and 2,3-dimethylbutane. They've got a difference in boiling point of 8 degrees centigrade. In this case, the 2,2,3-dimethylbutane molecules can lock into each other better, and so that they have a higher boiling point. They have greater intermolecular forces, leading to a greater boiling point. So in summary, what are isomers? They're two or more substances that have the same molecular formula but different structural formula. And this video focused on examples of how to draw chains. And so in future videos, we're going to look at other kinds of isomerism. Okay, thanks. See you next time.